welcome back there, functions folks, for some more trig fun. This is a little bit of review today stuff. 3-minute review here. I got it all laid out because I want to go through it fairly quick. You can pause it if you like. The sine of 11 pi over 6. The first step, of course, draw a diagram. Draw a diagram. And then I find out 11 pi over 6 is almost 12 pi over 6, right, which is 2 pi, almost all the way around. The related acute angle is pi over 6. I look up the sine of that in my chart is a half, but I know that only the cosine is positive in this quadrant, so I put a little negative sign there and I'm done. For the secant of 3 pi over 2, this is a special angle, right? This is not one of the ones that are on here. The secant of 3 pi over 2, well, I see the cosine is 0 because, remember, the x-coordinate of the spot where the terminal arm crosses the unit circle is the cosine. The x-coordinate is the cosine. But when I try and flip the cosine of 3 pi over 2 to get the secant, right, because the reciprocal's something over 0, that's undefined. 0 flips down to the bottom. The secant of 3 pi over 2 is undefined. Lastly, the cotan of 11 pi over 4. Well, it's kind of weird drawing an angle that's 11 pi over 4 because I know that, the straight line is 4 pi over 4. All the way around one spin is 8 pi over 4, which is 2 pi, but I got to keep going to 11 pi over 4. Well, I need to keep going another 3 pi over 4. So there's the terminal arm, and it's going to have the same ratio as the tan pi over 4. I'm looking at this part of my table, so it's 1, but possibly negative, right? And if I think of the cast rule, or all soup turns cold, only the sine is positive here, so I need to make that negative. But that's the tangent. I want the cotangent. I flip it, and you flip -1, you end up with -1, right? They flip. The negative's on the bottom or the top. It doesn't matter. All right. The second 3-minute review is a new bit of business, and I want to go through that fairly specially. That point lies on the terminal arm of theta, and they want us to state this stuff exactly. So what would be the first step, even though this might be the first time we've seen this one, or at least the first time since grade 11, is draw a diagram. Yeah. Okay, so let's draw a diagram. Where's this point P? Well, point P, I'm going to draw it is, and I'm not drawing this to scale necessarily, but it's 4, -3. P's down here, right? 4, -3 is that point, and it's on the terminal arm. Notice that this is not the unit circle because that's a lot bigger distance than a radius of 1. But what this is saying here is since the x-coordinate is 4 and the y-coordinate is -3, it's 2 parts to a triangle, right? And if I wanted to state the cosine of that, the cosine of theta is just adjacent over hypotenuse. Well, I don't have the hypotenuse, so how am I going to get the hypotenuse? That's all together. I'm going to have to squish it in here somewhere, maybe in a different color so you know what I'm doing. Well, the hypotenuse I'm going to call r. R squared is 4 squared plus -3 squared. I could make that +3. It doesn't matter. Bing, bing into my calculator. 16 plus 9 is 25, and I get r equals 5. This is one of those famous 3, 4, 5 triangles. And so now I have the cosine of theta. There's theta right there. That rotation angle, P is on the terminal arm, is then still just grade 10 trig. Adjacent over hypotenuse is 4/5. And notice that makes sense that it's positive because according to the all soup turns cold or cast rule, the cosine's positive in this quadrant. That's great. What about the cotangent? Well, cotangent I could think of as the tangent flipped. the tangent flipped would be opposite over adjacent, or I could think of it as adjacent over opposite, right? The flip of tan is adjacent over 4 over negative 3. That's it. Done. Exactly. Cosecant. Well, I'm running out of room here. Cosecant is the flip of sine, right? The flip of sine is not opposite over hypotenuse, but hypotenuse over opposite. It's the flip of sine, and I can state that exactly. 5 over negative 3. It's negative. It's because the sine's negative. Great. Dandy. And those are exact. Exact. I never used my calculator. I never found theta. But now in part B, for some reason, they want me to find theta to the nearest 100th radian. Well, notice I might be tempted to grab one of these and just use my calculator, right? This isn't one of my special angles, so I know it's not 30 or 60, the related acute angle. I'm going to try and do this, right? Grade 10 style. I do that, the inverse cos, and remember this is your calculator's in radians now, and I get 0.64. Well, certainly that's a lot more. This angle is a lot more than 0.64. Well, our calculator, if it can, will give us the related acute angle. So this is a little bit backwards. This angle here is 0.64. So what's theta actually? Well, theta is actually almost 2 pi. It's 2 pi, subtract the related acute angle, 0.64. And then I get 5.64 about. Okay? So sometimes your calculator lies to you a little bit. It'll give you the related acute angle only because in this case we put in the cosine, which is positive in the fourth quadrant. It tricked us a little bit, but I think we got it now. All right, that's the 3-minute review. And now on to today's stuff, which is kind of reviewish. Of course, I have a Restall spin on this. Solve this equation. How do we solve trig questions again? Draw a diagram. What do we mean by drawing a diagram here? I don't know what theta is, right? I don't know what theta is at all. I am going to draw a diagram, though, because there's some different information given here. I'm given that, I don't know where theta belongs, right? Is this, this theta here? Is it here? Is it here? Is it here? Is it here? I don't know. Well, kind of I do, and I'll tell you why. Because I know wherever the terminal arm crosses the unit circle, it gives me the x-coordinate and y-coordinate are the cosine and sine. This is the y-coordinate. This is telling me the y-coordinate is 0.4. The y-coordinate is 0.44. Well, where's the y-coordinate of 0.44? Well, if this is a unit circle, that's one and that's one. So 0.44 is about there. So that point right there has a y-coordinate of 0.44, right? Well, I don't know what the x-coordinate is, nor do I care. But what I do know is that's one possibility right there for theta. I'm going to call that theta 1, this little one right in here. Well, there are other values, right? I could have it over here. This could be my rotation angle. Right? That could be my answer because this also has a y-coordinate of 0.44, right? 0.44, it could be that angle. Notice I couldn't have any down here because the y-coordinates would be negative. Now, problem. There's two solutions there, right? But how do I know theta isn't supposed to be once around in there, or twice around in there, or 3 times around in there, or 4 times around in there, or 5, or, how many solutions have we got? There's an infinite number of solutions here. So how do we know how to state them? Well, usually there's a little bit of a of a disclaimer at the start of these questions, all right? And I skipped it on purpose to make that point. They usually say solve for theta is between 0 and 2 pi. These are what are called the principal solutions, okay? And so we're only going to stick to these two solutions. Well, how do I get them? Notice theta 1 is just this value in here, and I actually can get it from my calculator, right? This was maybe your first instinct to pound this into the calculator, and you get an answer here of 0.46. Notice this angle 0.46 is also the related acute angle, right? That's the related acute angle, and the calculator wants us to give us the related acute angle, and I usually call the related acute angle alpha, 0.46. So this little angle here is also the related acute angle, 0.46. So how do I get the second angle, which I'll call that theta 2. How do I get theta 2? Well, theta 2 is, where's my related acute angle? There's my related acute angle there. Well, it's almost pi, except for the related acute angle, which is 0.46. So if I wanted to state what theta 2 is, it's pi subtract the related acute angle of 0.46. And in your calculator, you just put in second function pi, and don't use 3.14. Use your pi button exactly. Pi subtract 0.46 is equal to 2.68. Notice these are the principal solutions. If I wanted to do the general solutions, and this is extra learning for funsies. In general, I could think of the solutions as 0.46 plus any number of spins. And remember, a spin is 2 pi. Theta 2 is 2.68 plus any number of spins. So this is a way to demonstrate the infinite number of solutions that there are, where n, by the way, is just an integer. That's like a thick z to show that n is an integer. Okay, now this, by the way, is my, and we'll get to the other ones in a second here, but this is my general method for solving trig equations. Is how do we do it? First of all, the first thing that we always do is draw a diagram, right? That's the first step, diagram, and then we might use our calculator. Diagram, calculator, and after that, we can get the second solutions by thinking about a combination of what the diagram's telling us and what our calculator's telling us. So it's diagram, calculator, think. That's how we get all of the solutions. I'm going to pick it up again in example 2, although I think we're getting close to being there, or part 2.